Good morning. We're going to do chapter 5 word problems now. These problems are going to be counted towards your test. All right. Let's take a look at number 1. So the first thing you always should do is read the problem, the whole problem. So one number is 3 times as large as another. The sum of the reciprocals is 8/3. Find the two numbers. Okay, so let's let one number be x. So then the other number is going to equal, let's see here, one number is 3 times as large as another. So if this one is x, if it is 3 times as large, that one's going to be 3x. The sum of their reciprocals. Okay, so sum means addition, and the reciprocals. Well, the reciprocals is you flip it. So this one is going to be 1 over x, and this one would be 1 over 3x. Okay, so that's the reciprocal there. So the sum of their reciprocals. So I'll get this set up and go 1 over x plus 1 over 3x is, well, that's an equal sign, right? Equals 8/3. All right, so now we're back to where we were in yesterday's lecture. I have 2 fractions over here and 1 over here, and I won't need to solve it because I got this equal sign here. So I'm going to find the LCD and multiply each and every term by that LCD. So LCD equals 3x in this case. So each term is going to be multiplied by 3x, 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 and 3x. Basically, we multiplied both sides by it, and it gets distributed to everything. All right, so now we're going to cancel out. That x will take that out, and I am left with a 3 right there. This 3x takes out that 3x, so I'm just left with a 1 right there, and this 3 takes out that 3, and I have an 8x. So this gives me a 4 equals 8x. Solving for x, so I'm going to divide both sides by 8, and I will get x equals 1/2. Okay, so if x right here is 1/2, what is this other number? So I'm going to take that 1/2 and I'm going to plug it in there. So I'll have 3 times the 1/2, multiply straight across, and I'll get 3 over 2. So those are my answers right here. This one and this one are my 2 numbers. Okay, so let's go take a look at number 2 now. I'm going to get you started on this one, and you will need to finish. The sum of a number and its reciprocal is 13/6. Okay, so we're going to let one number be x. The sum of a number and its reciprocal. Okay, so the reciprocal is the other number, so that is going to be 1 over x. The sum is addition. Okay, so we're going to add those guys together, and we'll get x plus 1 over x is our equal sign, equals 13/6. All right, you guys take it from there. This next one I'm going to get you started on again, and you will finish up. The sum of the reciprocal of 2 consecutive even integers is 3/4. Okay, so we're going to find those integers. And I want to point out, integers are like counting or natural numbers. So some examples of positive integers would be like 1, 2, 3. 0 is an integer, and negative integers are -1, -2, -3. So we got whole numbers there, okay? So you're not going to have something like 3/7 or whatever. All right, let's go look up here. The reciprocal of 2 consecutive even integers. Okay, so if one of them is x, how do I get to the next even integer? I'd go x plus 2. So the sum of the reciprocal, okay, so that's going to be 1 over x, and this one here will be 1 over x plus 2. We're going to add those guys together, and it's going to equal 3/4. Okay, so it equals, there's the sum right there. So our equation is going to look like 1 over x plus 1 over x plus 2 equals 3/4. You guys take it from there, and the code word is going to be lilac. Number 4, a boat travels 14 miles up the river in the same amount of time it takes it to travel 34 miles down the same river. If the current is 5 miles per hour, what is the speed of the boat in still water? Okay, when I work these type of problems, I love to use this table, okay? It makes it so much easier. And this is a distance equals rate times time problem. Okay, let's check this out now. A boat travels 14 miles up the river. Okay, so that's our distance, and they're going up. So I'm going to put 14 right there. In the same amount of time it takes it to travel 34 miles down the same river. Okay, so it's going down the river there. Okay, if the current is 5 miles per hour. Okay, when you're going up the river, isn't the current actually hurting you? I mean, you're having to put more work into it and everything. So this is going to be x minus 5 because the current is fighting you. When you're going down the river, the current is actually helping you. So this is going to be x plus 5. Now, do I have a way of figuring out what time is? Okay, so up here, if I come up here and solve this equation right here for t, so let's divide both sides by r. So t equals distance over rate. Well, here's my distance and here's my rate. So my time here is going to be 14 over x minus 5. And my time here is going to be 34 over x plus 5. Now up here, it says it takes the same amount of time. So we're just going to set those guys equal to each other. I'll have 14 over x minus 5 equals 34 over x plus 5. All right, we need to solve for x. Well, I have one fraction equaling one fraction, so I can use the cross multiplication. I can go, okay, that's 14 times the x plus 5 equals 34 times the x minus 5. Then I am going to distribute and get 14x plus 70 equals 34x minus 170. Since my highest power on the x's is to the first power, I'm going to get all my x's on one side and all my constants on the other side. So I'm going to subtract 34x from both sides. I'm going to subtract 70 from both sides. And I will end up with a, let me see here, a negative 20x. Those guys are gone, they're opposites. Here's my equal sign. These guys are gone because they're opposites. And a negative 240 when I add those two guys together. Okay, solving for x, so we're going to divide both sides by negative 20. Those cancel out, leaving me an x equals, that cancels, negative divided by negative is positive, and that's going to give me a 12. Okay, so the boat is going 12 miles per hour. Okay, number 5 works the exact same way as this one right here, except for you have an airplane, okay? You're going to have a headwind and a tailwind. So think about, when you have a tailwind, the wind is actually helping you. If you have a headwind, it is fighting against you. So if I were you, I'd set this up, I'd go, the distance, rate, time, like this. And then over here I'd have a headwind and a tailwind. Okay, so it works the exact same way as this one here, so good luck on that. Now the next problem we have, number 6, an inlet pipe can fill a pool in 16 hours, while an outlet pipe can empty it in 24 hours. If both pipes are left open, how long will it take to fill the pool? Now this is a work equals rate times time problem. So what we're going to do here is divide both sides by rate, and we're going to get time equals work over rate. Okay, so let's take a look at what we got here. An inlet pipe can fill a pool in 16 hours. Okay, so in 16 hours, it can fill that pool. So I'm putting that down here. That's my rate. And work, we're not quite sure. Okay, so we're going to put that X up there. While an outlet pipe can empty it in 24 hours. Okay, since it's emptying the pool, we're going to say minus. Okay, we're not sure how much work is getting done, but we know it can get done in 24 hours. Okay, so that's my rate down there, and this will give me one full pool. All right, now we're back to what we have been doing. Let's find our LCD using those two numbers there. So my LCD equals 48. I'm going to multiply each and every term by 48. 48, 48, and 48. Don't forget this 48 over here. That's where most people miss this. They do lovely work here and forget that 48. Okay, so 16 goes in here once, goes in here 3 times, so that gives me a 3x minus 24 goes in here once, goes in here twice. That'll give me a 2x equals 48. 3x minus 2x gives me 1x. So it will take 48. Number 7 works the exact same way as this. It's going to be a bathtub problem, and one faucet's going to fill it in 10 minutes. The other faucet can fill it in 15 minutes. So this time both faucets are helping each other. So instead of having a minus sign there, you will have a plus sign in it. So give that one a good try. And the second code word is going to be bush. Good luck on that.